Okay, problem 7.25 says the switch in the circuit is closed at time equals 0 after being open for a long time. So it wants us to find the current of I1 and I2 before at time 0 minus, which means on the negative portion of time. So before the switch, then 0 plus after the switch, right? Immediately after, right? So I would think about these as like immediately before and immediately after. But yeah, I'm gonna go ahead. I'm gonna use this circuit right here. I'm gonna analyze it and do a circuit analysis, right? So I'm gonna call this 1 volt here, V1, or call it V2. I would consider this my V1. Doesn't matter. V3, V4. Right. So then I would define my current IS. I can say I3. So actually, I'm gonna call this current across here IS, and then I'm gonna call this I3, I4. Okay. KCL IS is equal to 100 milliamps plus I3. So then, since I2, well, one thing we want to note is that since this circuit has been this way over a long period of time, we short circuit, so then I4 is going to be equal to 0. Therefore, I2 is equal to IS and equal to I1. And right, so we denote as I2 equals to well, let's write the equation. Let's start with I3. Let's go left to right. So EFC I3 is equal to 1 minus V2 over 20. I2 is equal to V2 minus V3 over 5. I1 is equal to V3 minus V4 over 2. And then call this I1 as well, doesn't matter. I1 is equal to V4. Oh, I forgot to, I always think this is implied when I'm doing it in my head. Sorry, I should have mentioned this. I'm going to consider this my ground. I1 equals V4 over 3. And then we have our variables are going to be V2, V3, V4, IS, I3, I2, I1, I4. 1, 2, 3, 4, 5, 6, 7. 4. Let's see, IS. I'll conclude I2 equals I1 plus I4. 4, 8. Yeah, that would match it up. All right. Let's go ahead and do our equations here. So IS equals 100 times 10 to the negative 3 plus I3. 4 equals 0. I2 equals IS. 2 equals I1 plus I4. 3 equals 1. 1 minus V2 over 20. 1 equals minus V4 over 2. 2 equals 2 minus V3 over 5. I1 equals 2V4 over 3. S I1, I2, 3, 4, 2, V3. Cool. All right, so it's going to be our values. All right, and these are our values at time less than 0. So we notice that our I2 and our I1 are the same, right? So 1, just tells, explains our part 1. So now let's do part 2, and let me copy this image really quick. Go. So what happens here, once it goes 0, then our switch, once we close our switch, current's going to go here. So cancel this part out, right? So I'm going to, yeah, this part is canceled. So then I'm going to label my node, call this, hold up, right? So, well, we got to consider, since we're looking for in part B, we're looking at instantly after. What's going to happen is looking for a T. This would more be this. So we're looking. How would I explain this? So we want to account for V3 and V4. We want to take V3 and V4 as our these values here as well. So let me call this V3, V4. Right. So our V3 and our V4 don't change. But our currents do, because the current one portion of the circuit is closed off since that switch happens. Right. So I'm gonna go ahead and analyze this. I'm gonna tell you. So see this. There's no independent source. I'm gonna call this IC. So then this should be also I2, right? You notice that this 5 ohm resistor with this 3 ohm resistor share one node, so we can recombine them. So I can say this. Say, or let's make it more accurate. Right. Call this I2, I1, and IC. All right. Okay. So insert more space. Okay. So our KCL, right? KCL I2 equals to IC plus I1. Equation for components. I2 equals 0 minus V3 over 8. Well, yeah. I1 is equal to V3 minus V4 over 2. Our IC is equal to 2 microfarad. And dV3 minus d4 over dt. So we don't even need to use maxima for these. Right. So our I1, we already know instantaneous. Well, I1 right after would be 0.5 minus 0.3 over 2, right? 0.2 over 2, 0.1 amps. And then our I2 would be 0 minus V3 V3 is 0.5 over 2. And it's going to be 0.25 negative 0.25 amps. Okay. So then for part C, explain why I1 0 minus equals to I1 0 plus. So these equal each other because this capacitor acts as an open circuit. So current decides there's no current going here. That's why they equal each other. So I2 equals I1. However, when this switch closes, this capacitor doesn't act as an open circuit. So then our KCL changes. So yeah, charge starts to flow away in this capacitor. So those C and D, I kind of explained them. You should understand how a capacitor works. A capacitor essentially just acts as a battery. It acts as a battery because it stores charge, but a battery, the difference between a capacitor and a battery is that a battery will store charge and will last essentially longer. We'll be able to store way more charge, whereas a capacitor, it it stores charge, but it needs to have it. It essentially there's a limit. It acts like as an exponential. There's a limit, and at this point, it will reach actually it's like this. The charge and then discharge once the switch happens. So yeah, that's my 7.25.